So this is a small demo of how I approach this type of exam questions, specifically in this case the AWS Certified Solutions Architect Pro questions. I took the free samples that come in the Tutorials Dojo, as this is stated in the blog post. I'm going to do 5 questions. It might be possible that I may do one, or that I may do them wrong, or not all of them, of course, but can happen that I may do 1 or 2 wrong. I've done this once, but long time ago, so this is really uh, a live demo of how I approach the questions and how I think about the answers. So let's get started. So this category is CSAP, so continuous improvement for existing solutions. A car parts manufacturing company installed IP cameras along its assembly line. These cameras are part of the quality inspections as they take photos of each car part and find defects by comparing them with a baseline image. To improve the accuracy of detection, the company used Amazon SageMaker to train a machine learning model that contains baseline images and common defects. Upon detection, the workers should receive feedback from the Linux server in the on-premise data center that hosts an API for the IP cameras. The company wants to make this solution available even when the factory's internet connectivity is down. So once we get this, we know, and this is highly probable to be IoT Greengrass, which is the solution for IoT solutions, and specifically in context of poor internet connectivity. So, which of the following options is the recommended solution for deploying the ML model that meets the company's requirement? So we need to deploy the existing model. That's also important. So deploy an AWS Outpost server on the local data center to create an AWS private cloud. Deploy Amazon SageMaker on this server for ML training and leverage Amazon recognition with its computer vision capabilities to detect defects among manufactured car parts. So we know this is not going to be the correct answer, specifically because it's saying that's going to train something, and what we want to do is to deploy the already existing model. So it's we don't even need to understand a lot of AWS to know that this is not going to be the correct solution. Let's get to number 2. Request for an AWS Novel Edge compute optimized device. This can provide the computing power for the ML training model. Well, again, it's talking about training an ML model, so this is not going to be the correct answer. Deploy the AWS IoT Greengrass client software to another local server. Run ML inference on the Greengrass server from the ML model trained. Okay, well, this is highly probably the correct answer. Leverage AWS IoT analytics to collect data from the captured images. Run machine learning analysis. So it's talking about analysis, which is like machine learning analysis doesn't exist. So definitely we go with IoT Greengrass. It matches all our assumptions. So we first read the question, we thought, okay, this is mostly based on the knowledge we know, this is most probably going to be IoT Greengrass, like, well, what AWS product or how would I approach this? And we would say, okay, well, this is most probably going to be IoT Greengrass. Once we read the questions, then we know that 2 of them talk about training models, and while the questions are talking about deploying an ML model, so we can discard the first 2. And the last one is also not accurate, because it's talking about running machine learning models analysis, which is something also that's not. So this question, although we have the specific knowledge and we know that it's going to be definitely the one we're going to pick, we have on top of that a lot of non-AWS knowledge that can help us out to know, in the case we don't know or we don't remember about Greengrass when we're doing the question, then we can get, or we can infer it out of other things. Okay, so this is the correct solution. We're not going to go through all the explanation. I really highly recommend you to do that when you do this yourselves. Actually, all of them do have this kind of very cool explanations of why the questions are, or some of the answers are incorrect. Second question. A popular news website that uses an Oracle database is currently deployed in the company's on-premises network. Due to its growing number of readers, the company decided to move its infrastructure to AWS, where they can further improve the performance of the website. Okay, so we're talking about migrating Oracle to AWS. The company earns from the advertisement placed on the website, so you were instructed to ensure that the website remains available in case of database server failures. This is another very, very important point. So we're talking about deploying Oracle in AWS and having some kind of high availability. The team of content writers constantly upload new articles every day, including the wee hours of the morning, to cover breaking news. In this scenario, how can you implement a highly available architecture to meet the requirement? Okay, so we'll need to put an Oracle database into AWS. So we have Oracle RDS provides the possibility of deploying deploying Oracle databases, so that's possible. Let's see what are the possibilities that we have. So create an Oracle database instance in RDS with Recovery Manager, which performs backup and recovery tasks on your database and automates the administration of your backup strategies. We're talking about high availability. So backup is not really a solution. So we need to have something more in the direction of, we're going to see it later, a multi-availability zone. So again, creating an Oracle database in RDS with read replicas, that is not so straightforward. You can recover and you can do a failover with read replicas. You can promote a read replica to standalone. To be honest, I don't remember now if you can do that specifically with Oracle. I suppose yes, you can definitely do that with MySQL or Postgres. You can promote a read replica to be a standalone server, but that takes time. There is a more straightforward there's a more straightforward option, that is creating an Oracle database with multi-AZ, with multiple availability zone deployment. That is the solution for high availability in RDS. And then we have create an Oracle real application clusters in RDS. That's out of the question, because that's not possible. If you need to put an Oracle RAC, you need to do that in EC2, because that doesn't come out in AWS. And that would be it, because in my opinion this should be multi-AZ. Yes, correct. So as we say here, so we have any time, like 99% of the times, you see something that requires high availability in RDS, in databases, you should aim towards multi-AZ. So you have all the explanations here. The following options are incorrect because Oracle RMON and RAC are not supported in RDS. That's what we're saying. Let's get to the next question. So a multinational corporation has recently acquired a smaller company. The solutions architect was instructed to consolidate the multiple AWS accounts of both entities using AWS organization. Okay, we're talking about again about organizations. So the solutions architect has set up the required service control policy to simplify the process of controlling access permissions for each individual account and organization units. Okay, so here we know we're going to be tested on SCP. So you need to, to do this correctly, you need to know service control policies, which is a topic that comes very frequently in the questions. It's a very, very important topic in this exam. So, however, one account is having trouble creating an S3 backend and is required to investigate the cause of this issue. The account has the following SCP attached. So we have, this is the SCP, it allows CrowdTrail, and it allows IAM. The main problem that we need to spot here is that whenever you write an SCP, anything that's not explicitly allowed by the SCP is denied. So that means that probably whatever, even if the user has an IAM policy, which is what's stated here, that allows all the S3 actions, and this is just a destructor because we say effect deny, not action, not resource. That means anything that is not an S3 action is going to be denied by this policy, because we have an explicit allow for S3 and an explicit deny for anything that is not S3. So based on the provided SCP and IAM policy. So this is a bit tricky because you see, and when you're seeing it quickly, and take into account that you don't have much time, this can be a distractor, because now it's going to ask us, based on the provided SCP and IAM policy, which of the following options could be the possible root cause of this problem. So the first thing you'll tend to think is, oh, here I have a deny, but watch out, because you have not action, not resource. So anything that's not on S3 and it's not on any S3 bucket is going to be denied. That's what this part of the policy says, but this part is not relevant to the problem that you have a problem creating an S3 bucket. So let's get back to the options and let's see what it says. Both the IAM policy and so our conclusion is this is not working because of the SCP. So both the IAM policy and the SCP are the problem? No. The SCP is the root cause because it does not support whitelisting of the whitelisting actions of the AWS resources. No. This is the SCP is the root cause since it does not explicitly allow the required action that would enable the account to create an S3 bucket. This is the problem. And then the IAM policy is the root cause because you have denied user permissions. No, that's the trap we were talking about. This is not denying us the access to S3. It's just denying us the access to anything else but S3. So, back to this. This is the correct answer. Yes, indeed. So, as we said, the problem is that it's policy that specify. So, if you write an SCP, so the SCP has an allow all by, well, depends on the strategy you use, but normally by default you have an allow all policies. That means that if you don't write anything and if you don't edit it, by default the SCP would allow any action. But if you write something, if you write it effectively, if you edit the SCP policy and you have allows, then anything else is implicitly denied. So that's something you need to know about SCPs in order to do that. So let's get to the next question. A photo sharing website uses a CloudFront distribution with a default name, to distribute static contents. It uses an ALB in front of an auto-scaling group of Spot EC2 instance deployed across 2 availability zones. The website has a poor search ranking in Google as it doesn't use secure HTTPS SSL on its site. Okay, this is a very, very content-specific question, so you need to know like how SSL works in order to do this. So, which of the following are valid options in order to require HTTPS for communication between the viewers and CloudFront? So, what do we know about HTTPS? Anything that is, for instance, self-signed certificate is definitely wrong because self-signed certificates do not enable HTTPS. So, this first option is wrong. This third option is wrong. So we have option 2, option 4, and option 5. So what we need to do, so we have the last one says configure the ELB to use its default SSL TLS certificate. That is not correct if we're going to use a CloudFront distribution. So the ELB cannot use its own SSL certificate name because it has the distribution on front of it. So what you need to do is configure CloudFront to use its default SSL TLS certificate by changing the viewer protocol policy, setting for one or more cache behaviors to require HTTPS communication, and then Set the viewer protocol policy to use redirect HTTPS to HTTP to HTTPS or HTTPS only. That means that whenever you access the CloudFront distribution or the website, it either transforms your HTTP to HTTPS or it just blocks whatever doesn't come through HTTPS. Correct. Again, you have all the explanation here. Well, ELB has no SSL certificate, and again, given that you have, as you can see here, you have CloudFront in front of the ELB, that's the one that receives the traffic, and that's the one that should support HTTPS. So, last question. A world-renowned logistics company runs its global enterprise e-commerce platform on the AWS cloud. The company has built a multi-tier web application running in a VPC that uses Elastic Load Balancer in front of both the web tier and the app tier, which with static assets served directly from an Amazon S3 bucket. It uses a combination of Amazon RDS and Amazon DynamoDB for the dynamic data and then archiving nightly into an Amazon S3 bucket for further processing with an Elastic MapReduce. Okay, so we have a lot of information here. We have a web application that has a load balancer with a web tier and the app tier. This has probably with static assets served directly from an Amazon S3 bucket. Okay, and then we know that it uses a combination of Amazon RDS. So this RDS is the database part of the multi-tier web application for the dynamic data, and then archive. Well, actually it uses both RDS and DynamoDB, and then it does this analytics process where it does it sends it to S3 for further processing with Elastic MapReduce. Elastic MapReduce is the Hadoop product, let's say, of Amazon. So where you can do processes with multiple workers, as you can do in Hadoop, or like you can put whatever you want out of the Hadoop ecosystem in Elastic MapReduce clusters like Spark, Hive, whatever. After a routine audit, the company found questionable log entries and suspected that someone is attempted to gain unauthorized access to the system. The solutions architect has been tasked to improve the security of the architecture from DDoS, SQL injection, and HTTP flood attacks, as well as from bad bots. Well, this is interesting. This is a question where they told you a lot of things about the solution, which you may or may not use. So it talked about load balances. It talked about RDS, DynamoDB, MapReduce, S3. But the problem is something else. It's asking about DDoS, SQL injection, and HTTP, so like attacks. Which of the following approach provides the most suitable and scalable solution to protect the infrastructure from these kind of security attacks? Okay, so it gave us a lot of information about how the architecture is built, but we don't know yet if all that information is important for the sake of the questions being asked, because we had like 4 lines of architecture, but then what we really need to do is just block these kind of things. And we know from our knowledge that DDoS is mostly blocked by the guard duty, and then SQL injection, HTTP flood attacks, and some of the so-called common attacks are normally handled by the firewall, by the AWS firewall. So probably the correct answer should be a mixture, because it's not saying, well, let's reread the question. It says, which of the following approach provides the most suitable and scalable solution to protect the... So it's not talking about cost. Here, sometimes, because, for instance, guard duty, not guard duty, Shield, AWS Shield, is expensive. Sometimes if they would be asking for instance, cost-effective something, then that's something you need to take into account, because that's gonna be important probably whenever you get to choose something. Let's get back. So we know it's going to be a combination of uh, firewall plus shield. So let's see what options we have. Establish a direct connect connection. Well, this has nothing to do, because direct connect is used to provide a physical connection between your on-premise server and AWS. We don't have any clue that the solution is run on a hybrid architecture. Actually, it says runs its global enterprise e-commerce platform on the AWS cloud. So direct connect is out of the question. We don't have anything where like direct connect is not relevant to the question being asked. Set up an AWS WAF and AWS Shield Advanced on all web endpoints. Launch AWS WAF rules against SQL injection and other common web exploits. Well, this is definitely what fits better to it's something that fits 100% to the question that's being asked. So let's pre-select this and let's check if the other two are relevant or not. Insert the identified suspect's source IP as an explicit inbound deny to the network ACL rules. Okay, so filtering by IP in the network ACL is access control list. Network ACL rules is a set of rules that you can set for the networks on the subnets to administrate traffic to the subnets. That's definitely not scalable. So we have suitable and scalable. Imagine yourself if you have to block every single IP that's trying to do an attack. That's absolutely zero scalable, and that's not the way you should be doing it. So that's definitely not the case, and actually it doesn't protect you against any other IP. Like, well, as we said, like you may be able to find 1, 2 n offending IPs, but that's impossible to maintain. So last option, create an identical application stack that acts as a standby environment in another AWS region by using an AWS CloudFormation template. Use AWS CloudFormation stack sets to deploy the new stack and configure the security groups as well as network ACLs on the EC2 instances. Use Amazon Macie to protect the data stored in the Amazon S3 bucket. Create a Route 53 failover routing policy and configure an active passive failover. Okay, so first of all, this is not addressing the problem, because what you're doing is you're creating a whole new failover environment, but that is not going to help you out in the case of you're not protecting anything. You're just creating another region. So basically, if something is wrong, then you make Route 53 failover to the other deployment in another region, but you're not really addressing the problem of the DDoS. So that's definitely not suitable for the scenario. Moreover, it's talking about data in S3, which is not really what they're asking. So it's Amazon Macie is it's not used to protect the data stored in the sense of an attack. It's used to anonymize the data. So it's used to find PII in the Amazon S3 in Amazon S3. So it's also not relevant to the question or to the problem that's being addressed. It's like what we need to tackle is the problem with DDoS, SQL injection, and HTTP flood attacks. So definitely the one and only possibility is WAF and AWS Shield Advanced. Correct. So this was a small demo of how I approach these kind of questions. I hope you liked it. Of course, once you get to more to do more practice exams, you're going to find yourself with different scenarios um, where you need to approach it with the other techniques we've seen. We haven't seen so much here of going towards simplicity, maybe in this last question, but again, this was like, in this case, it was like just not relevant. But sometimes you may find yourself with solutions that might be possible as stated in the blog, and then you need to go always towards the simplest one. We haven't seen any of these here, but I encourage you to take the exams and do practice, and then write me if there's anything you see. I hope you liked it, and let's meet in another demo.